Okay, let's go and get started with what we're going to cover today. And today we're going to talk about, we know how to do drawing stuff in Pygame, so make circles and lines, but a lot of times you want to have text on the screen, like you want to see how many lives you have, or the score, or a timer that's counting down, or something like that. So today we're going to spend a little time talking about fonts and images, and in other words, how do you get text on the screen, how do you get images on the screen that are made in an art program like Photoshop or Paint Shop or something like that. Okay, so first off, a quick review. A surface is a data type that stores pixel data. So the screen is made up of little pixels that are each colored red, green, have a red, green, blue component. And we've been using a display surface to do all our drawing. The display surface in Pygame is a special surface that whose pixels are connected to the window on the screen, or if we're in full screen mode, the screen itself. So in other words, when you're changing a red or green or blue of that, it's showing up on the display. When we do pygame.display.update, we see that on the screen. So the display surface is really just a special surface. So today we're going to look at using other surfaces to display font rendered text. And we're also going to look at loading and displaying kind of data that comes from an image file that you would load up. So in other words, if you're making a tank game with mummies versus tanks, you might go into an art program like Photoshop and do the art that you want for the title screen, maybe the art that you want for the zombie animations and the mummy animations and animations for the tank, and maybe you draw bullets, and then you would display those. So we're going to look at how to do some of that today. Okay, so step one, first we're going to focus on font. So step one is loading the font. And what a font is, that's not text at that point. It's just a font that we can use to then draw text later or render text later. So there are two ways in Pygame to load a font, and they are as follows. The first one, pygame.font.sysfont. Notice the capital S and F in that, so sysfont. And then we specify what font we want, the name of it, the size of it, and then whether we want it to be bold or italic. And you could leave these last two off, and it would default to not bold and not italic. But if you wanted to have it boldface, you could say bold equal true. So in other words, this is kind of like in a word processor where you select the font, the size, and whether you want it to be boldface or italicized. One thing about this, though, is the name that we use here has to be one of the system fonts that's installed in your operating system. So in other words, sysfont would use a standard installed font. So if you're in a word processor and you pull down that little font dialog box, it has a whole list of fonts there. It would have to be one of those ones that's installed. And there's some ones that are by default installed on most systems, like Arial, Monospace, Times New Roman, Comic Sans, MS, or whatever. There's a whole bunch of those that are kind of installed by default, but you can pick any one of those by using the name. Arial is a pretty safe one. Monospace is a pretty safe one. It looks more like a typewriter, and Times New Roman is a pretty safe one. But note that if you try to put a name here for a font that it doesn't have, it'll just default to like Arial. So if you put in sysfont and then something crazy here that doesn't exist, it'll say, I don't have that font, so I'll just use the default operating system font, which is usually something like Arial. Okay, the second method is to use pygame.font.font, capital F, but no sys in front of it. And in that case, what we do is we provide it with a font file. And that allows us to make games that use a custom font that looks like, I don't know, like alien letters or blood dripping off the letters or whatever. And there are all kinds of places you can download free fonts. But that allows us to use those without having to have the user install them in the operating system. And as long as we put that font file in the same location as the program that's trying to load it, then it'll find it and it'll work fine. You could also put a relative path here and say like assets/somefont.ttf and put the font inside the assets folder. So your program would then access that through there. That would work. So, but notice these work the same way. The only difference is this one is a system font. This one is a font file. They're two a couple kinds of fonts that are supported by Pygame. One is called a true type font, which has become kind of the standard font across not just Windows machines, but X Windows, Linux machines, and Macs. And those usually have a .ttf extension. Sometimes it's all uppercase, sometimes it's lowercase, but it's a .ttf, which is true type font. And the other type is an older format for fonts called .fon. So it'll support both of those font files. So if you can find a font that you like somewhere on the internet, download the TTF or .fon file for it, put it with your program, and then you can load that without having to install it in the operating system. All right, so after that, though, you'll notice that both of these return something that we're storing in a variable. And what's being stored in that variable is a font object. So in other words, we're saying, kind of like when we create the display surface, we say, create the display surface using pygame.display.set mode and make it 800 by 600. Display surface at that point, and after that refers now to that window. This is kind of the same concept, except now this variable name that we put over here, whatever we put over here, in this case my font, but we could write font 1 or end credits font or whatever we want here. This is just a variable name. And that variable name is now referring to that font object that got created that has a font this size in this typeface that's either bold or italic or neither or both or one or the other. But this font object we're now going to use. So after we have a font object, we're going to use that font object to now render text. So step 1 was loading the font and creating this font object. Now that we have the font object, we're going to use that to render text. So we would use the name that we set for it. So notice back here, I called it my underscore font. Now we're going to use that. We're going to say my underscore font dot render. Now we put the text that we want rendered here inside of a string. And then we set this to be anti-aliased, either true or false. And the difference between those is, I don't know if you're kind of gamers that are used to playing PC games, you've probably seen anti-alias settings in your games. Same thing on some console games, you can turn anti-aliasing on or off. But what essentially anti-aliasing does is when you are dealing with a pixel display like the screen, and it's a grid-based system, we have rows and columns. If you're putting something that's kind of slanted on that, you'll end up with kind of this jaggy appearance of it, where it jumps down from one row to the next to the next. What anti-aliasing does is it kind of blends those together in a way that makes it look smoother. But that extra blending that has to get done there also takes a little more CPU time to compute those blends to make it look smoother, so it's a little bit slower. So if you have this as true, the font will look a little bit smoother, a little bit less blocky. If you have that as false, it'll render faster. So they give you control over that, so you can decide whether you want it to be anti-aliased or not. And let me see if I can find an example here to show you what we're talking about here. Okay, so here's I can switch the screen over. Let me switch this over real quick. So here's what we're talking about with anti-aliasing. Notice that we have this grid of pixels without anti-aliasing on this line. You'll notice it looks kind of jaggy. It's got these little stair steps. And if you look at it here, let me zoom in a little bit on that. If you look at this version over here, you can kind of see that kind of granularity to it. With anti-aliasing, it kind of says, well, I'm going to compute how much of that line would have been visible, and I'm going to kind of make it a little bit smoother. I'm going to add some grayscale pixels in here, so the effect it has on your eye is now something that looks much smoother than without the anti-aliasing. So that's essentially what the anti-aliasing is doing with the font, and it's up to you whether you want that turned on or turned off. So you can set that there. The next thing is the color. We want the foreground color to be the color of the font. And then the next thing after that is background. And if you leave off this last one, it'll be transparent. If you put a background color there, it'll be kind of like a highlighter over the font. So you'd have like a box that's this color in the background. If you leave it off, it'll be transparent. Now what this is going to return to us, notice this still hasn't drawn anything on the screen yet. This is going to return to us a text surface. And this is a surface just like the display surface, but it's sized just to fit this text rendered in this color on that color background. And now we have that surface. So step 2 is it creates that surface, and that surface is off screen, so you can't see it. Imagine like a rectangle or a canvas that's now off screen. So we're not going to see anything. We have one more step to be able to see things, and that's to copy what's on that canvas onto the display surface. And that's done in step 3, which is a technique called blitting. What blit actually stands for is kind of block image transfer. So essentially we're taking a rectangle of pixels and copying them from one surface onto another one. And the way that this works is like down here. So ds.blit, the thing before the dot blit is the surface we want to blit to. So we're saying on the display surface, we're going to blit. And then this is the surface we're blitting from, the text surface, which is what we kind of created over here. And then this is the upper left corner we want this to start at. So it's always the upper left corner of that, well, from your perspective up here, the upper left corner of that box. So again, if this were the text that's being rendered, it's going to be this upper left corner here that's going to get blitted onto the display. That's the position, the X and Y of the position we want the upper left corner to be. And notice I could move this around. I could have variables there and say put it at 0, 0. It'd be all the way in the upper left. Put it at 100, 100, 100 over, 100 down. I could change this around. And that's how we're going to have those graphics move around later. These next two are, we don't have to provide. They have defaults of none, meaning that we're blitting the whole thing, but I can specify a source rectangle within this image if I wanted to. Since I want to blit, but not the whole thing, just cut out this one little section and blit that. That can be useful for sprite sheets, as we'll see later. With fonts, we probably would leave this off. Probably leave that off. This special flags allows for blending options to say how do you want that blitted. And if you're used to something like Photoshop, where you can have additive or subtractive or a multiply when you layer those pixels on top of the other ones, this lets you specify how you want to do that. But you can leave these off and only have the first two if you want. All right, so let's look at a complete example. So here's a complete example. I've used that yellow highlight there to indicate the things that are kind of new or specific to the fonts. So here is step 1, create the font object. And here I called it my font with no underscore or anything there. And then down here, I render it, or I render the text. So my font.render, that creates the surface. And then I blit that surface onto the display surface with ds.blit. And notice here I'm blitting it at a random location, and I'm repeatedly doing this over and over inside the loop until they hit the escape key. So if we run this program, we get that, and it actually will fill this up really quickly. Just bear with me for a second. I'm going to switch over to running the entire program live so you can kind of see that run. Okay, so let me switch over so you can see what I'm doing here. Okay, so here's the program. Notice there's the program, the same one what you just had there. In this case, I'm rendering game over, and I'm putting it in a kind of a random color at a random location. Let's run that and see what we get. And you'll notice when we run that, it'll completely fill up the screen and keep writing over that. In fact, it's doing it so much you can hardly see that it says game over anymore. It's filled it up so quickly. Maybe you can still make that out. But you'll notice that I've completely filled up that entire screen now with greens and yellows. And that's because I picked kind of random colors for that, but it's saying game over over and over again. And we could change this around if we wanted to. We could make if we want a bigger font, like put 64 here. Now the text is much bigger. Or if I want different colors, Or if I wanted to say different text, but notice those 3 steps. Step 1, load the font. Step 2, render the font or the text to a surface. Step 3, blit the surface to the display surface. You're always going to have those 3. Now, one thing that's probably important to note is notice that I loaded the font before the main loop. I probably don't want to have the font be loaded over and over again because that has to go out to the operating system and load that file into memory, which is going to slow things down. So we probably want to load that font. And one of the other things that I should point out here is you could have more than one font if you want. You could have this one that's 64 for the game over message. You might have a different one that is 12 for the heads up display for the scores. It's up to you to pick whatever fonts. It's usually a good practice to load all of them before the loop, so you're not constantly accessing files in the middle of the game. Now, if it's just a game over message, maybe you load that later on rather than at the beginning, so you load the font for that and do that at the beginning. All right, so let's switch back to the presentation now. We've got a little more stuff to cover here. And, but notice there's the 3 steps. Okay, images. So moving on to images, loading an image basically creates a surface for us. So here's an example of the line of code. So Mario_surf, that's a surface that's going to hold this Mario.jpg or Mario.png or whatever it is that we want to load. But that'll take this file and load it into memory into a surface that's not visible yet. So it's going to load the image into image data from that file into a new surface that it creates. The new surface isn't visible until we blit it, just like with fonts. They weren't visible until we blitted it. And then the various, there are various file formats that are supported. Pretty much any image file format you can think of is supported. The typical ones would be like a JPEG or a bitmap or a PNG file. PNG files are probably a good choice because they have a pretty good compression ratio and they support transparency. JPEGs do not support transparency. So if you want to have something like a Mario where the background is transparent, you're going to have to use a file format like GIF or JPEG, or GIF or PNG, and not something like bitmap or JPEG. PNGs are probably have become the standard recently. All right, so once we've loaded that surface, that image into a surface, now we have to blit it to see it. And again, just like with the fonts, we should probably load the images before the main game loop so we're not constantly loading files over and over from the hard drive. And why? Because that would slow things down considerably. All right, so step 2, after we've loaded the image into a surface, blit it. So here's the Mario surface, ds.blit, just like we would with fonts, and the position. And this will support the other features as well, the source rectangle and the special flags for blending options. So notice that I did mention that here. It supports the source rectangle, which is really useful for sprite sheets. And so you could load one big sprite sheet with a lot of little sub-sprites inside of it. And the special flags could be used for how we blend the thing when it blits. In other words, is it kind of layered over the top of what's already there? Or is it just kind of a one-for-one replacement of what's already there? And let's look at a complete example of this as well. All right, so here's an example of that. And in this case, I highlighted the 2 lines. Step 1, loading the image, again, outside of the loop, before the loop. And then the main game loop, blit the image. And in this case, I'm just blitting it to a random location on the screen. All right, so what does that do when we run it? Well, I had this Mario.png that I loaded, and I just blitted it everywhere. And notice because I used PNG, it has transparency, which is why you can see, like, here's a good case here where you can see the hat, and you can see what's behind it was transparent. Let's take a look at that code running live here for just a second. So let me switch over to where you can see that. Give me 1 second here. Okay, got that loaded. Let me switch over to where you can see it. Okay, so here's the program. So that's the entire program right there. Same one that was in the text. Let's run it. And there it is running. And you'll notice that we just get kind of those Marios blitted over the top of each other. Notice that the blit operation is pretty quick. That's fairly speedy because we're blitting one, updating the entire display, blitting again, updating the entire display, and repeating that as fast as that loop will run. You know, it's just hundreds or thousands of Marios all layered on top of each other there. The Mario Party. All right, anyway. So that gives us a pretty good example of what we're talking about there. Notice I never cleared the screen. If I did do a clear screen here, like ds.fill, now it'll be kind of that Mario jumping all over the screen to different places rather than layering on top of itself. And you can get an idea of how quickly the blit is actually happening like that. I'm not even sure if the recording is picking it up. Picking up how quickly that's happening. But watch how fast it will fill up the entire screen. Okay, so we're pretty much already done. And that's just blitting those randomly. Okay, let's go back to the presentation. Okay, blank surfaces. Again, a surface is just that rectangle of pixel data. We can create a blank one that's whatever size we want. So the way we do this, pygame.surface, capital S, for surface, and then we specify the size. So a lot like set mode did for the display surface, but this is creating one and it's returning that surface object as a variable. And once we've created that surface, we can do stuff to it like we would normally do. We could draw a circle onto that new surface, and then we could blit that new surface onto the display surface to see it. So this would be an example of, for example, like in your previous lab where you drew that ghost, using a circle and a rectangle and some lines and some other circles. You could do that once to an off-screen surface and then just blit it to have it show up rather than having to draw it all over and over and over again. All right, so all surfaces, the display surface, any other one, we can draw upon them using the drawing commands, pygame.draw.circle, .line, .lines, .rectangle, .rect, and all the other things. You can also blit things to them, new surface.blit, and then blit some source surface onto that destination. You can also blit from them onto the display surface. You can have pixel data access. You could say new surface.getAt and get the RGB color that's at some X and Y offset into that surface, or you could set a pixel and turn it on inside of at some XY location, some color on some surface. And you can also, every surface, you can get the dimension. You can do get height, you can do get width, and that'll tell you how many pixels wide it is, how many pixels tall it is. Now there's one other category of things we can do with surfaces that we're going to look at right now, or look at today, and that is surfaces can be transformed, meaning that we can do new surface, here's a surface, some surface that we have, that already exists, we can then transform it by rotating it. So in other words, rotating a surface is, here's this rectangular block of pixels, rotate it, and that's going to create a new rectangular block, which might not be the same size as the original. It's going to create a new rectangular block of pixels. It's not going to change this one. It's going to produce one as if it were rotated by this angle. And that angle is in degrees. And that's going to produce that new surface. You can also scale it, so make it bigger or smaller. And the way you do that is you give it the surface and you give it a new width and a new height. And so you can kind of squish it. You can scale it on whatever dimensions you want, however you want. But you can do that. There's also this transform that allows us to flip the surface. So that means kind of making a mirror image of it, either across the vertical or across the horizontal. And that can be useful, for example, you have that Pac-Man and it's going this way and you want to make it go this way. You can just flip that and then you only have to draw one graphic and you can make it go both directions. Or you might use the rotate for that too. Have it go this way and then rotate it. So now it's going up, rotate it, now it's going sideways. So you can do these things with that. There's also one that does both a rotate and a scale all in one step called rotozoom, where you basically say, here's the surface I want to rotozoom. This is the angle I want rotated at, and this is the zoom. One thing about the zoom is that's a factor, not the size that we want it to be. So for example, 1.0 would mean leave the size alone. 2.0 would mean make it twice as big, zoom into 2x factor. Making it 0.5 would make it half the size of the original. So this is like a zoom factor on a zoom lens, or the camera on your smartphone, or on a copy machine, or something like that. So those transforms allow us to do that. Now let's go ahead and try using some of those here. So I'm going to go back and let's go back to this example that we just had a second ago, this one. And let's, rather than displaying the Mario surface, I'm going to say new surface here. So right before this, I'm going to say new surface equal Pygame.transform dot, let's do rotate. If you remember how rotate works, here's the tooltip. It says takes a surface. In this case, we want it to be the Mario surface. And the angle we want, let's put 45 there. And let's run that and see what we get. So now you notice the Marios are all tilted at 45 degrees. And let's just, for fun here, let's make this let's go 0 to 359 to get it all different angles here. And so now you'll notice we have Marios that are at various random angles. Some of them facing the way they were, some of them facing up, some of them facing, we have 360 possible ways now we can blit that. And let me slow this down and get a little bit. So Pygame.time.delay, and let's do 10 milliseconds. So now you can see it a little slower filling in with them being at different angles. And let's, for fun, let's actually, after we load the Mario, let's say the Mario we decided was too big. So I could up here, I could say Mario surface equal Pygame.transform dot rotozoom, and the surface is going to be the Mario surface. And the angle, I'm going to leave the angle alone, but I'm going to make the scale 0.5. So it should be half the size of how it was earlier. And now notice we have smaller Marios rather than the bigger ones. And let's make it a quarter of the size, 0.25. Now we've got little tiny Marios. And if we wanted to, we could actually, I suppose we could actually make it so we get big ones and small ones. Now, one thing to note, if you make these too small, you're not gonna, you probably can't even tell what that is now. It's lost some of the ability to resolve what that thing is that we're drawing. But notice that that rotozoom feature is actually pretty cool. One thing to watch out for there, or be careful for, if I make these too large and I start with an image that's too small, here, we'll just make it twice as big. And I don't know if you can see it or not, but it looks a little fuzzier now that we've made it big. So there is a thing, if you start with an image too small and you make it bigger, the resizing actually does okay, but it's not going to look as smooth as if you had the assets already in that size. Here, let's do a random number here. Random.uniform. Uniform generates a random number between two ranges. Let's go between 2.25 and 0.75 of the original. So this is going to make different sized Marios. So some will be small, some will be large. Here, let's make this, so this goes to 1.0. Let's make that 0.1. So now we're going to get some super tiny ones. Okay, we're only doing that once. We should probably be doing that inside the loop so we get different ones. So we're only calculating that once. So let's try this. I'm going to do this differently. I want to do it to new surface inside here. Oops. New surface. This is going to be new surface. All right, let's try that. So now notice we get some of them that are really tiny, some of them that are much bigger. And one cool thing about using those sizes is you could actually have it so we change the size dynamically with, like, for example, keys that get pressed. And because things that are far away from you appear smaller, things that are closer appear bigger. You can kind of see that here even on the camera here. So here's this Domino's cup. Notice that that pattern looks much bigger as it gets closer, much smaller as it moves farther away. You can actually, in Pygame, using that scale factor, approximate something that looks like or simulates something being farther or closer from you. So you can do kind of a pseudo 3D kind of game with this by saying, take this image, scale it down to this size. That makes it look farther away. And as the monster gets closer and closer to you, it gets bigger and bigger. And then eventually it gets up where it's right in your face, and you shoot it and it dies or whatever. And so using those scale factor things can be really useful. Also, that ability to rotate things. For example, you could have it so that the thing as it comes toward you kind of wobbles back and forth, make it look like it's walking. And really what you could do is you could take individual, like a torso and the parts of the body, like the limbs, and you could have those be separate things that are rotated and blended on top of each other to make a character. And you could also do cell animation, which we're going to look at later on in the class. Let's go back to the presentation just briefly here, and then that's pretty much it for what I want to cover today. So let me switch back over to there. Okay, so all of these, you might want to play around with these a little bit, but the transforms are pretty useful. They can allow us to do some really cool effects. And they're all very quick as well. And so we're going to be using those when we go to start making games here coming up. So that's it for today. Work on the labs. Look for a new lab. One thing I do want to mention is there is going to be a midterm coming up, not next week, but the week after. And I'm going to post a study guide for that, give you time next week to study, to go through that. So just be prepared to look through the study guide. The study guide will have like an outline of everything we've covered so far in class. Make sure you understand that. Also make sure you do the labs. There will be one more lab before the midterm that will be posted as well. So look for that to go up either today, look on today's webpage, or at the latest next class. I think I'll get it up there today. So look for that. Other than that, stay safe, wash your hands. If you go out around other people, wear a mask. Practice social distancing, and be safe. If you have any questions whatsoever or any kind of problems, shoot me an email, send me a text message, message me on Discord. However you need to get a hold of me, do that. I'm more than happy to come in and meet face to face. If you're struggling with things and need help, just let me know. We'll try to answer your question over email first, and if that fails, then I'll come in and I'll see what I can do to help. All right, everybody stay safe, and I'll see you soon.